Maybe I was wrong, even once wasn't anything. Yeah, I could say that you didn't need any part of me. Yeah, maybe it's not me, you should be the one on your knees. So if we had another chance, I would never let you steal my if we had another chance, I would never let you steal my glance. Bring me back to life.
I get lost inside my thoughts, and when I start to think, oh, the tunnel closest starts to end up on the brink. I tried so hard, but all these scars, they cut so deep, I bleed. I fell so fast from heaven, it's like someone clipped my wings. Now I'm falling, and I can't see the ground. Can we stop this gravity? It keeps bringing me down. I can't breathe and I don't wanna die. Can we stop this gravity? 'Cause I don't wanna say goodbye. I forgive the pain you gave to me so long ago. Sleepless nights I laid awake just begging to let go. I almost got to suicidal thoughts, but you stepped in. An angel sent from heaven showed me how to live again. Now I'm falling, and I can't see the ground. Can we stop this gravity? It keeps bringing me down. I can't breathe and I don't wanna die. Can we stop this gravity? 'Cause I don't wanna say goodbye.
Sometimes I have to keep on breathing in. My lungs are filled with too much pain. All the shadows of the past that I'm so leaving, they held me in my sleepless nights. And I'm drowning in the noise like a free fall, walking along my path for too long. Save myself from the visions in my mind. Save myself from the war I have to fight. And I can take it all away. All of my dreams are fading. Save myself from the visions in my mind. Save I'm drowning in the noise like a free fall, walking along my path for too long. Save myself from the visions in my mind. Save myself from the war I have to fight. And I can take it all away. All of my dreams are fading. Save myself from the visions in my mind. Save myself. Save myself.
Hello everyone, we are back Saturday. We're doing some binary exploitation. Gonna continue on with the nightmare course. Just gonna bring it up here in a second. Why is it not up yet? Okay. Give me a second, I can't connect into my VM. It's waiting on the network. Is that because I disabled? Excuse me. Okay. So, how do I want to fix this? What the? How can I do that? There we go. Right. Oops, what the, ugh. Let's see if that works. I was having trouble updating the Ubuntu packages on the machine, and when I tried to get the latest from the apt repository, wasn't able to connect, and then turned out I had left on I was working on a project where I'm using man-in-the-middle proxy, and I have config set up so that I can man-in-the-middle any web traffic coming from a VM that I'm running, and I had that going with a different VM, but I forgot to turn it off when I started the VM for this, and that's why it was trying to go to the proxy, but the proxy wasn't running, so all the requests were failing. And in the process I had of trying to debug it before I realized that's what was going on, it was trying to connect via IPv6, it looked like, because it was showing me IPv6 addresses in the error messages. So I went into syscontrol and turned that off, and then I left that turned off, and when I rebooted, it wasn't able to bring up the network because I guess it needs to bring up IPv6 by default or something. I'm sure I could configure that off, but it doesn't really matter. So, unnecessary explanation for why my machine didn't want to start. All right, so we're back in though. We can do our hack in practice. Was I on the not stack pivot anymore, right? Or we are still okay? We're in the one right one, yeah. Inside the hack, okay. Yeah, we'll have that going. We'll have GDB going as well. Okay, so just to recap, did I not shut this? I must not have shut this machine down properly because I also got an error message about like a still open lock file on apt. I guess we'll recover it. Yeah. Okay, so the process that we learned about that we could use for this one write situation, where we can write a single 8-byte memory read, write 8 bytes to anywhere in memory that we want, anywhere that's mapped in at least, and so what we were able to do is make use of that write to achieve. So it first leaks us one of either a stack address or a address within the binary, and it's a statically linked binary, so we get everything from that. So we can get the base of the binary if we leak an address from within there. And what we do is we first leak the stack address. That tells us now where we want to overwrite, partially overwrite at least, in order to jump back to the beginning of the function that asks us what we want to leak. So then we can also leak the address within the binary itself. And now that we have both of those pieces of information, we've got the stack address and we've got the base address, we can use the base address to find where the Finney array is, which is an array of pointers to functions that should be called when the program exits. And what we're going to do with that is use the second write that we get, because when we loop back to get the second leak, we also get a second write. And so we're going to use that to write into the Finney array another call to the function that allows us to write anywhere. So we get a third write. And we use that third write to write the second function in the Finney array, which it feels like, oh, why are we going in this like repetitive loop of like write another entry in the Finney array and then use that entry to get an additional write to write another entry in the Finney array. The key here though is, first off, there's only 2 entries that we can put in there anyways. That's just the size of it right now. With that second one, instead of using the write from the second entry to write a third entry, for example, we will use it to overwrite the return address of the function that loops through that array, calling all of those functions. So when we overwrite that return address, now we get 2 more calls to give us a write function, basically. It's called do overwrite. So we're going to call do overwrite twice every time we loop through the Finney array. And on the first call, we'll use that to write some data for our ROP chain. On the second call, we will use that to overwrite the return address to go ahead and loop back and go through that array yet again. So each time we go through the array, we get one write to our wrap chain and one write to let us loop a second time, or one more time, I guess. So this is where we're at. There's a few things that we need to figure out before we can get the writing of the wrap chain going. And then I had put down a list of the remaining things that we need to do. We need to find the address relative to stack adder where the libc csu fini function, that's the one that goes through that array, where its return address is stored on the stack. So we need to like work out where that is relative to the stack adder that we have leaked. Based on what I was seeing in the walkthrough, because all of this is basically me going along with what was in the walkthrough, it seemed like that was going to be a fixed address, so we shouldn't have to worry too much about like that being the wrong, us calculating the wrong offset. But we do need to figure out what that is, so we'll just run it in GDB, I guess, and we'll be able to tell from that. And then we need to actually create the wrap chain. That should be pretty straightforward. We can get all of our gadgets from within the binary. And we need to write a little bit of code to loop through the wrap chain and actually do the calls, do the work that will trigger the do overwrite stuff. And that should also be, you know, not too difficult. We've got a little function to make the write happen already, so we'll just call that twice per entry in the wrap chain. We will have to pick somewhere on the stack to put our wrap chain, and then we need to find another gadget that allows us to pivot the stack to now point at the beginning of our wrap chain. But I had an idea in regards to that last part, which seemed interesting to me, which is basically, what if we arranged the location of our wrap chain so that when we finish writing the whole wrap chain, the first entry in it happens to be overwriting the address that libc csu fini returns to. So the final return from the libc csu fini function will just return into our wrap chain. We don't have to worry about the actual stack pivot stuff. I think we can, if you just calculate the length of the wrap chain and then do a little bit of math, because actually the return address for CSU Fini seems to change on every call. It said it's something like it goes up by 8 after each time you say repeat the function, basically by overriding the return value. It turns out that the return value is now 8 later than it was, or is it 8 higher? Presumably it's 8 higher, but maybe it's lower. We'll have to see. But basically, we'll have to take that into account plus the length of the wrap chain. But then I think we can just work out where we need to start putting, and we'll have to put them in reverse order. I think we'll put the last entry in, and then keep adding entries until the first entry is the one that overwrites the return address for the last element. I think that should be fine. Yeah, so I think we should try that at least. But the first thing we want to do is we still got to do the first 3 of these steps. So we got to find the relative address for where libc csu fini returns, where it uses the return address. So this is the function that we are worried about. And I think we might be able to just do like disassemble that. Oh, it does a jump? That seems weird. Okay, so it's not doing a... So I guess we need to overwrite the one from the underscore Finney function. Yeah. Why does it subtract 8 from RSP and then add 8 to RSP? Seems kind of weird, but okay. So I think this is the address that we're concerned with, though. So we'll put our breakpoint at Finney plus 8. And then let's go ahead and just run our exploit as is. Okay, that's fair. We don't really have this stuff yet. Can we write somewhere innocuous? Let's write okay, so we still need to write something because we have, I believe we did the leak, but then you need to write somewhere after the leak. And so we're just going to write to a place on the stack that shouldn't overwrite anything, should allow the program to exit as normal. But we've already leaked the stack address, so... Or you know what? We could probably just say run. Let's leak that stack address. And then... So this is our stack address that we have. And what do we have in RSP? E348. Okay, so that is a difference of just 48 hex. Okay. We'll just continue and let's run it again. We get, well, we get the same address. I feel like maybe let's not run it in GDB because I'm a little worried about maybe GDB, since it turns off ASLR, maybe it also has some impact on the, like, how those stack addresses would differ from each other relative wise, but we'll find out. Okay, so I think I can run this exploit now. 1288 and just continue. So why is there a read issue? Why did it hang up? in read. For do leak, we're doing a write. And this is the reading of the integer, right? So why is that an issue? And we could definitely do like plus try that. No, it's still. All right, let's turn interactive back on, I guess. I think that's probably the issue then. It's getting hang up. Why are we back to this? Oops. Okay, so what the hell? Now we got a sig fault. So we write the address for do leak, and that comes back and lets us leak the address of do leak itself. And that is our we calculate this stuff, but that stuff doesn't matter. So then doing another write should like I don't see why it what is going on? Ooh. We're not doing that. We can do this, but yeah. Oops. Why? Because this write should not cause any issues, and I don't think it does. So what the hell? How does it come back? How the fuck? Alright, so let's put a breakpoint on the return here. Figure out why it's doing what it's doing. Okay, so the first time we have overwritten the return address so that we go back to do leak. Seems correct, straightforward. We'll continue. The second time, why does it think we've overwritten it to go back? Is that a different address in do leak? Yeah, so it's not going back to the beginning of do leak, it's going back to the end. So now, if we go here, that'll return into CSU init. I don't know why I need to. Why is it returning into init? Shouldn't it like return into why now is it returning to the beginning of do leak? What have I done that magically gives me another? So that's 708. Oof, we gotta go all the way back up here. So much spam. Okay, so we're here at this is when we do the overwrite, and then this time we're at 6E0. RSP is at 6E0 when we return in here. But also, I didn't write the address of the do leak function, so, and we're at 708. That's not like, what the fuck? How have I broken this so hard? And like, it's broken in a way that's good for me, but really shouldn't be. Should not be what I am seeing in terms of behavior. All right, let's run it again. We're going to put a breakpoint on libc csu init plus 139. I mean, like, maybe that'll work. It's going to be mapped in a different address, but GDB seems pretty good at that. 1334. So, okay, the first return makes sense that we've overwritten that. And then the second return, this is our address. 1C60 is the top of the stack when we return from do overwrite the second time to do the normal return. And then 1C88, so 28 higher, is our return address from libccsu. Okay, so we'll continue. For whatever reason it goes back. Let me check it again, see if it's still plus 28. Okay, so we got EF0 this time, so we'd be looking at F18 if it's plus 28. F18. Okay, so it's always plus 28 from where we are when we have this overwrite. So okay, let's do it one more time. Now, before we actually go, let's look at the value that we have at here. 1ZG plus 28. So that's the pointer to go back to the beginning of do leak. So it's already been written, which makes sense. We've already done the second write. So is there some weirdness here? Oh. Okay. Can we get anything out of that then? So I think, okay, I didn't recognize this. Or wait, no, that's not. Well, yeah, I thought maybe for a second that the place that we had written to the first time was also the return address from libc CSU init, but it's not, because that address is CE98 and this one is CE88. So they are 10 hexadecimal bytes off. If we just run the program normally, it doesn't do this. Pretty sure. So if we just do one write, we say stack, and then let's go ahead and throw this into R2. We can get the decimal version of this. And let's add 16 to it, or yeah, let's give it a shot. It doesn't like that. Interesting. It only wants 8. No, it wants more than that. Why doesn't it like the decimal version? But definitely didn't. Hmm. That was also, okay, so if we just do this, yeah, I don't know how to actually interact with this thing on the in the terminal, because it's not like trying to get a string from the terminal. It's trying to just do read with a certain fixed number of bytes, but the terminal doesn't know how to just say pass these number of bytes in. We could do like echo yeah, so I don't know, it doesn't loop like that, but it does when we use our exploit. So let's try something. Look at this address plus 10 hex. So not the, that's not what I want. This is what I want. This one plus 10x. Yeah, so that's already been overwritten. Oh, it's right here. So why does that get overwritten? What does this look like? Right. We've got our 7 bytes, and then the last one overwrites this byte. Perfectly what we anticipated. So let's put our breakpoint in do overwrite plus just before the call to read. So plus 71 and continue. Sure. Okay, so now we haven't done the read call yet. We do have why is that happening? Like, we literally have not written anything to memory yet. And so why is the return address out of CSU, or perhaps like why is the return address from do_leak going to libc CSU init? I guess that's maybe the question, right? Because it should go back to main. So something has overwritten this address for some reason. How the fuck? I guess this is just a very poorly written bit of code. It doesn't seem like that would be the case. Let's just detach from it and run it ourselves. Why does it get to... Right, okay. So, because we're finishing up CSU init, we're going through all the init functions before the program starts. That's perfectly fine and understandable. And then, I don't know, we'll leak a stack address, do whatever. Now it's going to call read, and here we still have that same setup. So it surely seems like doleak is going to exit into libcsu init. And that is so weird. Why wasn't I seeing that before? Well, 1, 2, 3, 4. Okay. Yeah, I don't know. So do nup and gonna return to doleak, which adds 18 to RSP. Okay, so that all seems fine. Are we messing up the stack somehow? Right, because this is going to go back to main. And then we'll go through, we'll run exit handlers, whatever. Okay. Now, this one, we do the read, come back to doleak, to the beginning of doleak, exactly as we wanted. We'll continue. That'll take us to the read for the second one. And then this takes us to the end of doleak. And now, yeah, why do we have this stuff? We're going to add 18. Where did we get to the original? Run exit handlers. Okay, so it must be something to do with us right. If we haven't done the add yet, this is what it looks like normally. And this is what it looks like now. So we are off by 18 already. I guess so. So somewhere in our choice to return, so I'm pretty sure we're going back to the beginning of this function. So we're going back to sub 18. Oh, but we didn't. But we should have run add 18, right? But we are overwriting the return address for do overwrite such that does that help us at all? Probably not. I think it's not sustainable, or it would be really annoying to try to work it out. But I think the issue is in do overwrite, we are returning directly to the beginning of do leak. So we are skipping these, I'm pretty sure. On the first go round. And really maybe what we want to do is have this return address, have this return instruction be the one that goes back up. That's a little more repeatable. Because we're getting offset minus 18 right, yeah, minus 18 hex each time we do this loop, which in this case happens to work out to where our loop goes back into a init, but I think that doesn't help us. I mean, we can definitely try something, right? And see. So now that we know then it's going to ask us to do a leak again. We could just leak true, doesn't matter. And then we could say write stack adder plus 1000 and then see what it looks like in interactive mode. Stack dash. Okay, and then we get a seg fault. So it doesn't happen to line up that if we then subtract another 18 hex, this function ends up returning back to somewhere interesting. It just sort of, we lucked out on it, I'd say. The last time, I guess, I don't know where this instruction is located, but 2C8. Doesn't matter. So we want to calculate where the return address for ret is, the one that originally has main. So let's run the exploit, and on the first call to read, we want to write to 30. So stack pointer is 1370, and we want to write to 1380, 1381, so that we can write 8 bytes and overwrite that, I think. Right, because we are overwriting this one, I'm pretty sure. 70 minus, yeah, so we're writing here and overwriting this. So we want it to happen here instead. Okay, that's fine. And I think that solves a question I had last time. So we want to write to, yeah, plus B. See what it looks like. All right, so we're at 190, and we should be writing to 190B, which is going to be, oh no, we want to write to, sorry, we want to write to 21. Or just, no, just 11 hex. I was trying to do 11 decimal. Okay, so we're at the read call, 130 hex, and we're going to write to 141. So we'll write these bytes, and then this one. Oh, but this one is AB09, so we do need to write oh, see, that becomes trickier, because we would need to write 2 bytes worth, and we don't know what to have in the upper byte, do we? I don't think we know what to have in the upper byte yet. So now I'm very curious how they go about it in their exploit code. So when they overwrite they go plus 18, and they write a single byte. No, they, oh yeah, and they just send a single byte. Okay, whereas down here, whereas write keyword, so they write, yeah. Interesting. I didn't think that would work. I thought we had to send, well, okay. But they're writing a 4. Like, what is the, A04. Makes no sense. How does this work? So I'm going to write to the stack. Whatever that is, address is plus 18 hex. They're going to write a single byte that is the value 4. I don't get it. I don't get how that goes to do overwrite. Or rather, goes to do leak. And yeah, I mean, they do the same thing here again. But it just makes no sense to me. What is the... Like, as far as I can tell, they would be jumping into, like, this byte, which is completely misaligned, unless they had a different version of the binary, and their version has these functions at different places. Here's their original write-up. B09 to B04. Yeah, I don't know what B0, like, theirs is a different binary somehow. Oh, okay, no, I get it. Interesting. So they do theirs not to the beginning of do leak, but to the call to do leak, which I would think still has the issue. It probably won't run into this issue because we would have then pushed another address on the stack. And so our stack will be one lower. And maybe this is the address that we would end up using. I don't know. I mean, I guess we could try that. And apparently you don't need to write all 8 bytes, which confuses me. I don't, like, read is a confusing fucking function, man. Just like how you signal that the pipe is closed or something, but then still can send data on that pipe later. I don't know, man. I guess it's just a matter of we're going to try to send a certain amount. So, okay, we're still overwriting the return address that do leak returns from. Oh, so that's why it doesn't have the stack issue. Okay. We can just do this. Okay. that seems reasonable. Then we don't have to worry about the multi-byte issue. I probably should have been able to work that one out in terms of real, like, determining that we don't need to write 2 bytes worth. Is there another place that we could return to rather than a 15 in this case? Some place that starts with AB09. I should be a little more diligent in trying to find other return addresses, which in this case happens to be just prior when we do the call to do leak. So okay, mystery solved there. That was a big detour. Okay, so now we are writing let's do this delete call. In here, and it's really, we don't even need a function for it, but why not? Okay, so then the next write that we do is into the Finney array with the override address. So we actually still need to do this, finding the CSU Finney return address. Let me say, oh, just give no argument. So I did. Okay. So we deleted all the breakpoints. That's fine. And we want to break at plus 60. Okay. So we actually don't want to do these writes. Yeah, this is the reason that I was doing like write stack header plus 100. Why not? Doesn't really matter. Okay, then now we're at Finney, and oh, this is the jump. I should have been paying more attention because we care what it looks like when we get to the ret. So RSP is E98 versus our EE0. That's what we were leaked. Which is the difference. It is a difference of 48. Did I see that before and I guess so. I'm all out of sorts. Okay, let's do it one more time and double check that that's consistent, at least between 2 different runs. Okay, so we've got E98 again? Why is it giving us the same addresses? Oh, it's not the same addresses, but the low, it just happens to be E for the, okay. So this stuff is pretty consistent at least. Okay. So, oops, or minus 48. Yeah, minus 48. Which is weird. If only because I would think that the return address for this would be higher up than than the return addresses for the stuff from main, but maybe all of these calls get scheduled and like are in a chain. I guess, yeah, so because we were at wherever so like what do we have at 8? Oh, well, we've closed it already. Yeah, I guess it's just because like main is here, and then we have Dooley can do overwrite, and they probably have larger stack frames or something, so they, or maybe smaller stack frames. So the address for this one then is lower down. It shouldn't matter. Okay, so we can get rid of the fake right, and then we want to do CSU Finny Ret, and we'll just go back up to the beginning of, and this one is actually Finny Ret, because for whatever reason we jumped to the Finny function, which is just that, but whatever. Okay. So you can see how that goes. No encode on line 22 or line 51. How do we want to do this? P64. Okay, so at this point we have gone through two more times. So delete that. This is the first overwrite to go back up. This is the second overwrite to put the first entry in the Finney array, which then, when the program starts to exit after that write, it goes and calls do overwrite again. So we get this third write, which writes the second, or technically the first entry in the Finney array, the other one. When do overwrite finishes, then the Finney array code comes in and ends up running it a second time because it runs this one now, the one that we just overwrote here. So we get this third overwrite. This is the one that should overwrite the return address in the Finney function. And we don't have two more writes to test stuff with. But yeah, then we come back up to Finney. If we run, it's going to be waiting for stuff. Okay, so then we can okay, so what I'm testing out, because I remember reading this in the walkthrough, this is going to set up the Finney array for us, and this one will get us to loop back so that we can keep doing our one write to add a ROP chain entry and one write to loop back to start for the next ROP chain entry. So we're just writing a fake thing for right now. Here we are writing to loop back again, and what I remember reading was that this address actually changes, is offset by 8 or something every time. So I want to verify if that is the case or not. Yeah. Okay, so we get the first loop through, and that one works. So continue, and then we get the second loop through, and that one does not work. Now RSP is 770, and I think we need to subtract 8 from it. So that'll be 810, which here, yeah, so we just subtract 8 from it each time. Okay, that's fine. Then what we need to do is say ROP chain is equal to whatever, and then for E in ROP chain, for entry in ROP chain, I'm going to do this. Let's see. And let's say I'm just sort of high level explaining it, not really getting into the details of the libc CSU Finney function. Okay, so now we need our ROP chain. So we've done the first one. What do I need? It takes so long between times, like actually doing a ROP chain that I forget what the hell we need to do. Okay, so our ROP chain is going to do all of these things, and we're actually going to so we're going to go through it backwards. And we need to figure out what all of these addresses are going to be. Okay, and then in here, we need to calculate the right address, and we'll need to the index easily in a for loop. I gotta do enumerate. That is old school though. Yeah, but I can, I guess, pass in. So I can say enumerate and pass in the reversed thing. Okay, so then we'll do I times 8. And we'll say minus instead. All right. Yeah, I guess we'll, because we have some fixed values in here, Do P64B. I was gonna try to add the base in here, but with these constant values, 3B, 0, and this one that's the string, we don't want to add the base to those. So we're gonna add the base up here. And we don't need the map. Alright, so now we're gonna do wrap gadget finder, no chop, and grep for top RDX. Oops, I don't need the pipe. Okay, got this guy. Gonna keep them nice and short. Or AX. And RDI. Oops. Just FA, okay. And RSI. And then let's do syscall real quick. That's going to be a little bit simpler. Yeah, I don't know. Let's just for organizational purposes, we'll have the one that's too long on its own line. So then this one is going to be like D-word pointer or keyword pointer. RDX, RAX. There we go. Do we not have one on its own? And what do we use racks for? Pop that string into racks, write it to an address. And we later pop 0, or we later pop 3B into racks. So doing the move to overwrite racks should be fine. I can use this one and not care. Okay, but then we also need to say base header plus that, and base header plus that one. Okay. Then I don't think we need command header. What was that from anyways? Oh, we do. Okay. That's just an address that we want to use to write our where to write the string. Then I don't know, that can be like .400 hex plus. Hopefully that's a thing. Shouldn't matter too much. Or maybe we can subtract 400. That's pretty far down the stack. Shouldn't be interfering with anything. So now we loop through and we'll write to some address this set of stuff. So what we need to do is calculate address of first ROP chain entry do this, I think. Okay, so we need to calculate the address where the Finney return pointer will be after writing the final ROP chain entry, which is basically just it's going to be Finney ret minus len ROP chain times 8. Is it len times 8? I think because here we write using Finney ret, and then our second write means that we now still need to go Finney ret plus 1, so that means the len option is fine. And we don't really need these parens up here. Okay, then if that's where the ROP chain starts, we want the start plus, because we're going to be writing at higher addresses. Is this accurate? Maybe we can't do it this way then. Right, if the address where the finish function return pointer exists in memory in the stack decreases by 8 on each loop, and popping is going to increase the stack address, it's going to a higher address, then that means we would need to have written our chain somewhere in the space that it's probably walking through. So, fine. I don't think we can do the nice short thing that I was hoping to do without the stack pivot gadget, whatever that is. Okay, so the start of the ROP chain is going to be at 200 minus. I don't know. It doesn't really matter. Oops. Do 300 hex earlier than stack address. And so then there's really no need to go through it in reverse. But we do want to skip the last one? No. Wait, okay, so we'll write the command address to stack address minus 400 hex. And the ROP chain will start at minus 380 hex. And then we will add I times 8 to it. Yep. Should take us up to like 310, minus 310 hex. Alright, then we need to find a gadget. I guess we should do up through the last one. Or do I need to... Okay, so we need a stack pivot gadget, which is probably going to like pop into RSP. Hey, we do have one of those. So if we pop into the stack pointer, then all we need to do is write the ROP chain start as the thing following that. So we would need to write fini ret minus len ROP chain times 8. Do we need len ROP chain plus 1? No, I think because this will be one higher than the actual return address, which is where we want our RSP, the value to be popped into it, to go. because the return address will pop that off of the stack when we hit the ret out of the fini function, and that'll move our stack pointer up to a slightly higher address. So I think we're good there. And okay, and we need to do this as, oops. Okay, then I think that should be enough. It's probably going to fail, but whew, okay. What do we get going on? Got an EOF. After, just go ahead and take out these prints. Let's put a few more meaningful prints out here. All right, so after ROP chain entry 1, we got a problem. That's interesting. Is this a bad address for it then? Where do I want to just do it? Okay. Why did we not hit Fini before this? That is weird. Okay, so our stack was F050. So if we're gonna subtract 400 from that, it's like EC50. And we're nowhere near that in terms of where our stack stuff is. So I think we're fine where we're writing stuff onto the stack. But yeah, why did we write ROP chain entry 0 and not get to Finney ret? Okay, so this is our loop. So let's just add it at the call and then we'll see how that goes. All right, so the call is, it's going to be able to tell us what it is. No. So this is set up the Finney array. Are we off by 1? Yeah, that's weird. I guess that makes sense. Okay. So that loop should have overwritten the return pointer. So now we come back. And then this write, wait, why did we get, because we haven't done the write yet. Okay, so we did that loop. All right, so we need to, I guess my +1 expectation was wrong, is all. I think that's the right address. Does that make sense? 060, no. Oh, not B8, but 98. No. Is it A8? But that would tell me where that goes to. Should be 780. Or, sorry, no, it should be 810. Okay, so it's minus 10 from where we're at right now. It'd be 90 rather than B8A0. So we should have 1 times 10 hex. Or and the other thing we could do is just sort of subtract from it as we go. Rather than be calculating it every time, but what am I misunderstanding? Right, let's so how do I say like show breakpoints? God damn it. There we go, info BR. Where were we at? 838. Okay. So after the first loop through, we are RSP is, where am I at? C10. Wait, why is that broken on the first loop through? It shouldn't be the first loop through though. So what the frustrating as hell. Yeah, we'll put that back on there. Alright, so if we walk through this, then why is this? Why is this the address that we have? 3B8. Is there a different Finney function? No? Okay. So we'll put the breakpoint here, and then okay, so now we've gotten there again. What did it look like when we were there last time? RSP was 748. And now RSP is 750. So it's going up 8. It's not going down 8. Why did I... Or... yeah, I think it's fine that it's... Let's try this. Which means maybe we didn't need the stack pivot gadget. Not that it's particularly complicated, but I like the idea of not needing it. What? Where did that come from? Did I do something weird? Okay, well, we wrote all the entries at least. We still got a sig fault because I didn't fix these other ones. There we go. Perfect. So can we... I don't feel like doing it, but I think since it actually was going up 8 each time, we could have done... yeah, let's give it a shot. No, now that I think about it, I don't feel like it. But we could have sort of like, let's say this represents the stack, all of these lines, where each line is like an 8-byte entry in the stack. So if this is the address where Finney uses, this is the stack entry that Finney uses to return from. We'll overwrite it once here, then the next time it's looking here, so we'll overwrite that one, then it's looking here, so we overwrite that. Eventually, it's going to come up to here, and this could be the start of our ROP chain, entry 1. And we just happen to meet at exactly the time that Finney gets to here, in terms of where it's looking for the return pointer and where we have written our ROP chain starting from the end going down. And we just meet in the middle, so to speak, and then this takes over and we just run each of our gadgets up through the chain. So we could have done it that way, turns out, because for whatever reason I got confused and thought that Finney was going down this way, in which case we wouldn't necessarily be able to write entries going up, like, because going through the ROP chain is naturally going to go up this way as it pops entries off for each of the returns. If Finney was going down, then we wouldn't have a way, we'd have to write it here. I guess we could write it after Finney, sort of each entry, but that we're then like overwriting stuff that's in the stack frame, I think, and or at least the parent stack. I don't know. Maybe we could have done it still, and I'm just not thinking clearly enough about how the stack is organized. But Doing the pivot, is a much more general purpose approach and definitely more reliable, I'd say. But maybe it doesn't have necessarily the perfect elegance for that idea, but that's fine. Okay, well, this one was difficult. If you ended up watching the previous stream, there's definitely stuff that I didn't know about or didn't put these pieces together in terms of how we could use all these different elements to achieve significant, like effectively achieve the ability to write enough to have a ROP chain and then get control over stuff. So yeah, had to resort to the walkthrough on this one. But even, just sort of understanding how it's done and then writing the walkthrough, writing my implementation rather myself was good. Gave me some degree of practice there. And yeah, I mean, I feel like I learned stuff out of this one. I think thinking back on it, I always feel like if I end up having to resort to a walkthrough or otherwise feel like I've sort of like given up or cheated a little bit on one of these, then I feel like I find myself trying to convince myself that actually I did learn a lot from it at least, so there's something from it. I don't know. We'll see how much of it gets retained, I guess. So the next entry, so we'll try to do one more. We've got about an hour left, and we'll see if I can get through one more. Maybe this one won't be as difficult as the Insomniac one. So this is from SecCon 2019. I wonder if that's just security conference. It's in Japan, looks like, Akihabara. This website probably doesn't like my... Yeah, it's a little better like that. CTF for girls. Wow. Okay. I feel like all the CTFs are for girls. But if you want to have, your own, I think it's just Japan. They have a slightly different take on how you might present something like that. I don't think this characterization would necessarily get the same level of approval from people who want to have more inclusivity in these kinds of competitions. There's definitely an aspect of like, well, maybe don't assume that everything for girls has to be represented as pink, or for women to be, first off, has to be pink, and then say it's for girls or something. There's definitely a level of like, that feels like a weird corporatist kind of pandering and playing into gender stereotypes and stuff more than would be necessary. Yeah, I don't know why it's called SecCon. Guess it's just it's a security contest. Okay, cool. So this one is called Sum. And yep. And also libc, just in case we need that. Okay. Which version of libc is this? This is 227.3 Ubuntu 1, and ours is 227.3 Ubuntu 1. So exactly the same, so we don't need to overwrite and make sure to use this libc. Then, yeah, let's take a look at the file. 64-bit elf, dynamically linked, and we saw earlier it is linked just to libc. And what is the security on it? No PIE. Okay, that's nice. Don't have to leak that. NX enabled, of course, we're in the ROP section. Canaries are on, so we aren't, unless we are sort of brute forcing or otherwise getting leaked to the canary or something, we aren't doing a straightforward overwrite into the return pointer of the stack frame kind of attack. And then we've got partial railroad. Okay. Small binary, of course, because it's dynamically linked. Let's see. Remove second. I'll have GDB going and go to main. So we can put in a sequence of numbers, and 0 is our terminator sort of, what do they call it? Sentinel value. And we put them in with spaces, it looks like. So read ints is probably taking in a buffer and splitting it on spaces and then getting it into an array, for which we then sum that array and do a printf. Okay. Oh yeah, and I always gotta, I always read too much into the stack thing. There's a stack canary here, but maybe we have an overflow in read ints and there's no stack canary in that. Or maybe the sum function has an issue, and if we put in integers that get interpreted as the entries in our ROP chain or something, then we can trigger a ROP situation in sum. Like maybe it's making a assumption about the size of the array, so that'll be interesting. Let's see. So before we call ints, first parameter, or read ints rather, first parameter is the address of local 40 on the stack here in the main function, and the second parameter is just 5. Then our sum function takes local 40, the same pointer to the same buffer, as first parameter. Then second parameter is whatever is returned from read ints, maybe the length, and then what is after? Yeah. Oh, sorry. Second parameter is this local 18, which, that is curious. We aren't using that elsewhere. Oh, okay. So previously we have moved 30 hex into it. Okay. And we zeroed everything in the stack frame basically from RBP minus 40 through RBP minus 10 hex. And it looks like RBP minus 10 hex is where we are storing the the actual sum value, which is interesting because it's not being passed in, and we aren't And we like, okay. I'm assuming 5 is the number of integers. Let's just look at what readints is doing. So we scan one number at a time, it looks like. And one is the number of things that we scanned. What does scanf return? The number of input items successful. Okay, so yeah, if we didn't get one thing from scanning and there's just one format specifier in there, so it's either 0 or 1. So if we didn't get anything, then we exit the program. Okay, so if we got something, then we okay, so it looks like, yeah, local 10 is our index into the array. 18 is the array itself, so that is coming in as the first parameter. I'm restoring Q words, quad words. What is 20? 20 is the maximum, I guess, that we will read in. So it comes in, it's going to be 5, and 8 is our, yeah. We have a stack canary in this function as well. Okay. So yeah, we basically scan up to 5 numbers. Okay. And we are passing in 40 RBP minus 40, so we can do 1, 2, 3, 4, 5. Yep. And then 18 hex is, it's going to be, or RBP minus 18 hex is 30 hex right now. We're passing that in as second parameter, and the array that we read the up to 5 digits into, up to 5 numbers into, as the first parameter. So first parameter is at 18 hex, and RSI is at 20 hex. Second parameter is at 20 hex. Okay, so maybe the 30 hex. Well, we'll find out. That goes into racks. We put, what? So just so that I am clear on this, Rax has 30. Oh no, we're adding 30. Oh, I should have. Okay, I thought that was a move for some reason. Okay, so RBP minus 40 hex plus 30 hex gets us this address. Okay, so then that address is stored in 18. Weird, but okay. And then 18, so it is the address of RBP minus 10 hex. Then that is presumably the location where we are storing the sum. All right. So yeah, it starts off at 0. Local C is going to be our index, I suppose, or the number, the counter for how many we've actually worked with. Okay. Set that aside for a second. That thought. No, okay, yeah, it's our index, and we are using that, getting the value. If it's not 0, then we get 1 plus that number and move that I see, yeah, we just increment the value there. And then we index into the array, get that into Rax, move the actual value into RDX, and add it in. Go back around. But this loop is not caring as long as we don't get to a number that is 0. This loop will keep going past the end of the array. It's not bounded, effectively. We do need to, but we're only reading in the effort to get a sum. So the canary isn't going to be triggered because we aren't overriding the canary. But of course, how do we get control over the return pointer? Because the actual reading in of numbers is properly bounded. So it's only going to read in 5 numbers, which doesn't overflow anything. And then this will just read a bunch of stuff and sum it, but it is going to it's going to store that in a local variable here. or no, it's not storing it in a local variable, but it's storing it in this address. So as long as it's not 0 by the time it gets to reading here, then it will read the next one. But again, it's still just this thing that results in the read. Maybe there's this is another one where it's really not obvious to me what the vulnerability is. I mean, there's a bug in it, but I don't see how that bug represents a vulnerability yet. I don't think, like, if I give this one, two, three, four, five, it does segfault. That's interesting. Am I misunderstanding the readInts function? $20 is the second parameter. Store it there. Then as we come down here, we get 10, which is our index. And we compare it. As long as our index is less than or equal to, so we actually read in 6 numbers. That's maybe the thing. 1, 2, 3, 4, 5, 6. Okay. So 1, 2, 3, 4, 5, 6. And that overwrites 18, which is the location where we are storing so we can overwrite 18, which gives us, has the value of where we will write the sum of the other numbers to. Okay. So that means we can calculate the address of where the return pointer is going to be on the stack. Well, shit, we don't know where the stack is. But we can write to the Finney array, I guess. Maybe we can just write it a one gadget value. Let's see if we can achieve that. So I don't know why the segfault was at 0, but okay. If we run it and we say like 1, 2, 3, 4, 5, 6, then we get the segfault, and it is trying to write to 6. and it's trying to probably write a value of 15. It's the sum of 1 through 5. So, or maybe it's going to add 16 into the sum. It's going to add 6 into the sum, so maybe it's trying to write 21. Oh, you know what? It's probably failing on the first right, because this is 6 is not a valid address. So, okay, let's figure out I'm gonna go ahead and move sum to sum. And quit out of GDB so we can reopen it with that. Okay, now and what did we say? Not stripped. That's helpful. Okay, so we have the address of the Finney array. We can go ahead and write to the first entry in there, I guess. And we can write our one gadget address. What if we wrote like did you see Apple's new Silicon and High? Hey Foon, I only watched a little bit of the developer conference thing, WWDC or whatever. So I didn't see whatever part where they were talking about. I guess they're gonna do ARM MacBooks, which I don't know makes sense to me. They've invested a lot in their iPhone stuff, and it's not like you couldn't make that stuff bigger scale in terms of more impressive cores and maybe more just more cores in the actual package. But yeah, I mean the difficulty is like trying to switch software and stuff over, but they've done that a couple decades ago or whenever it was they switched from PowerPC. So I think they're in well trod ground for them in terms of switching, and now they're going to have more control. I would assume their reasoning has a lot to do with like not wanting to feel beholden to, I guess I would not necessarily Intel, because I think they have also switched to using AMD in some cases. So they, but I think they, as a very large company, they don't want to be tied too much to one company. And even though obviously ARM is a single company, I'm sure that they're a big enough entity in relation to ARM that whatever deal they have already gives them a lot of leeway to do whatever the hell they want with it. So I guess it makes sense, but I'm not like really in the market for another Apple product anytime soon. I sold my MacBook a year or two ago, and haven't really missed it. And the new operating system changes didn't seem it's kind of underwhelming. The bit that I was looking at was like icon changes and changes to the UI of all the default apps, and I never used any of the default apps really. And then what I heard on Twitter is they made some like understandable choices in terms of trying to lock things down a bit more. It's understandable from the standpoint of trying to make a system that is harder and harder to exploit, even in the presence of like somebody has an RCE through your web browser or something. It becomes even harder to get like persistence into the kernel and stuff, because they've locked everything down so hard. Makes it more annoying if you're the kind of person that's trying to do development or otherwise like prefers not to have a very locked down system. But I think one thing that I read was like they've basically made it impossible to load binary like core shared object binaries based on a path. You now have to use a particular API call. So I mean, that, like, my first thought when I saw that was just like, oh, this is like almost a parody of how Apple normally is. In my viewpoint, Apple has always taken a standpoint of like, we're going to change whatever the hell we want on every operating system release, and if that breaks a bunch of people's stuff, well, too bad, you got to keep up. They're more than happy to like change stuff in a way that is convenient for them and makes their ecosystem of developers scrambling to try to work around the fact that they can't do the thing that they wanted to do in the first place. Like, I used to have a program that would take all the icons that get put in that like upper menu bar area and collapse them into like a sub menu, because I would have like 10 or 12 things or whatever, and I just aesthetically didn't like it to be filled up with stuff. So there was somebody that made a program that's like, oh, you run this program and you can move a bunch of those icons into a little sub menu. It's called Bartender, I think. And then one release, they're like, oh yeah, you can't modify stuff that's in the menu up there anymore, presumably for security reasons. But basically I had to like go into the sort of rescue mode or whatever, the like special key command to get into a terminal where you could mess with stuff before the operating system is loaded and like turn off a certain protection, and then I could install Bartender, and then I could reboot and turn that protection off again and stuff like that. But even worse when they just break an API. So in this case, like, they could break tons and tons of software that is perhaps poorly written, but was written with it's not terribly written. It's just like, maybe it would be smarter to have not written it that way. But now it's broken, or will be in the next release. And it just feels like they've sort of upped the ante of, hey, we're going to break stuff and like give you, a relatively short period of time to figure out how to fix all your stuff. So that part I didn't like. I mean, I always waited at least a few months before ever upgrading my OS, because so much of the developer related software that I used would break for a couple months, and then eventually they'd figure out what they needed to fix. Even though like they had developer, beta releases or whatever, those probably still weren't enough time for them to get everything fixed, or they didn't encounter all of the bugs until more people started using it. And it just feels kind of shitty to be like, hey, I'm not using a beta version of this OS. I'm using the fully released one, but I'm still beta testing for all the software that I need, because they change too much shit and then probably don't even mention half of the stuff that they change. So is it going to be harder to crack an iPhone now or Apple devices? I have no idea. I mean, the stuff that I was talking about with the MacBook, I don't think that would impact on whether the iPhone is harder to crack, unless part of that requires having a very unrestricted MacBook to achieve it. But I mean, I don't know if that is the case. I don't know how iPhone cracking works. I've never owned an iPhone, so it's never really been a area that I've put much like mental effort into learning how the jailbreak stuff works. I mean, it's neat from the standpoint of, I guess they're using, sort of a binary exploit of some kind. They're I don't know if it's necessarily a 0-day, but they're definitely doing something that is probably based on memory corruption or otherwise is getting RCE on the system and then using that to combine it with privilege escalation. You're just sort of hacking your own computer or your own phone in this case rather than somebody else's phone, but it's, I guess, the same techniques. So from that standpoint, it's interesting. And occasionally I've read about iOS based hacks, but like it's a whole ecosystem that I don't really understand very much. So I can't meaningfully comment on whether this will or will not impact the work of cracking iPhones. It sounds like it will make MacBook, if there was a scenario where you had to crack a MacBook or like root, jailbreak or root a MacBook, then that would be harder. But people don't need to do that for their own MacBook, so making it more difficult is really just making it harder for somebody else who shouldn't have access to your device to do exactly that, to gain root on it, which is the definition of a security fix, right? So it sounds, it's a good thing generally speaking, but it does two things. One, as I said, it like messes with developers who maybe are relying on existing functionality that is no longer possible or needs to be done in some different way that they've changed arbitrarily. And two, it's sort of, it goes in line with the whole making it less upgradable. It's just all, the more they lock this kind of thing down, the more it becomes like an iPhone from the standpoint of it's not really a device that you completely own. It's something that you are still very tied to Apple in terms of repair, replacement, etc. You don't have the ability to do everything that you would want with it necessarily, just from a software standpoint, for example. Although it sounds like all the protections they put in, you can go into that special mode or whatever and then turn it off. And that mode should only be available if you are physically at the computer in the first place. So, that's still pretty good protection against what most of the what is it called, like adversary cases or whatever. Generally speaking, they're not trying to protect against somebody who physically has access to your computer in the first place, but it just makes it more of a pain in the ass. And I don't know, the laptop that I have is a Lenovo, and yeah, they are less upgradable probably than they used to be, but they're still like, I went in and added my own hard drive in there. Maybe I don't qualify. I think that was one of the ones that they specified as like you're allowed to do that and still have your warranty, which I'm pretty sure I checked for that because I paid for the like somewhat more expensive warranty, and I wasn't gonna bother with that if adding the hard drive would void it in the first place. So it's fine. And then I don't know, the desktop is just like various components put together, so that one's pretty hard for any company to try to have complete control over it. So yeah, but it the drive is definitely towards devices that are more in control over by the manufacturer than by the owner of the device. And if you want to get into that, you can watch what's his face, Lou Rossman on YouTube, who does like repairing of Apple products and probably other various consumer electronics products, and he has a lot of opinions around the social and economic impact of making these devices harder and harder to repair, and why it's not real, like, at least on the repair front, it is not there's not a good, how to say it, there's not really a good excuse for it other than they know that they can make money from the repair process. And it also doesn't give them any kind of incentive to yeah, he's probably been on Linus a couple times, yeah. And I remember watching he went on a tour for a little bit, going to all these like state capitol buildings where they were doing hearings about basically changing the law in that state about whether you're, must create stuff that is allowed to be repaired by third parties and stuff, and he would be there to testify for why that should be the case, why you should be allowed to do that. And he made really good arguments. I remember when he went to Washington State, where I'm from, they were actually very receptive to the idea. Even the like conservative folks who tend to be by default on the side of whatever the biggest corporation is, rather than some little dude who wants to run a repair shop. Even they were like, well, yeah, it doesn't make a lot of sense why this phone is somehow different from every other piece of technology and every other product that we sell to anybody else in the entirety of our economy, that this thing is so unique you can't allow other people to repair it. Like, they always try to go down to the argument of like, oh, it's so like proprietary and secret. If you let other people do stuff with it, they would. It's trademarks and trade secrets, and yeah, just don't do it. That's sort of the nonsense they go to. Yeah, and I mean they'll do whatever they can come up with, warranty stickers and little bits of text in a giant agreement that says if you end up touching this device at all, you've agreed to this thing. Like, it doesn't necessarily mean that it would work, but the way that our court system operates, like, unless you're the kind of person that's going to spend a lot of money on lawyers to combat their spending a lot of money on lawyers, then you're never going to find out if that weird trick that they're trying to pull is going to be considered legal or not. And since they have a lot of money that rides on keeping that trick available, they're going to employ a lot more force than you probably have to combat them in court. And so they're nobody's really going to even bother because they can foresee how that would not work out in their favor. But it's just one of the ways in which capitalism allows giant corporations to dick over, in this case, consumers. The more traditional thing of capitalism is the employers dicking over their workers, but they'll also do it to the consumers if they can. Yeah, R.I.P. Aaron Swartz. He tried to do a decent thing, and that's when they'll try to throw everything at you. It's not even like the WikiLeaks stuff or other whistleblower stuff. Like, he was just like, hey, people should have this information, and a bunch of corporations are like, you should go to jail for the rest of your life, and we're gonna make sure that you do because we can charge people $20 to look at an article that we didn't write. And barely spend money to publish and stuff. So yeah, I don't know, all of this stuff is fucked up, basically. Okay. All I can say is, what happened to Aaron Swartz and what happens to the black guy who works at Amazon who was trying to form a union and then was relentlessly slandered by Amazon management in public because he was trying to unionize his sort of the warehouse that he worked at. They're all part of the same spectrum of class warfare, let's say. So, if you feel for Mr. Schwartz and what happened to him, which is awful, and if you can see the dislogic of it, let me find out. This one? I'm trying to remember. I think it comes up fairly often, but there was like the context in which I was talking about this one guy is because some like high up management guy who's sort of like I don't know if he's a marketing guy or what, but he was going on about Black Lives Matter and how much all of this stuff, but he was also, if you look back a month, he was part of the process of trying to slander this dude who happened to be black, who was fighting for a union, and it was calling him like, he just wanted it because he's lazy and blah blah, like the sort of like, oh, you don't really care about the life of this black guy if it means that your company is going to have to pay more money to their employees. Chris Smalls, I don't know, maybe. Is it, what did he say his name was? John Hopkins? That makes it hard to search for. It's not like these are like really famous people, right? They're just individual workers. But if you work at one of these places like an Amazon or a Walmart or McDonald's, certainly the really large companies, and you try to advocate for a union, which is totally legal, they're going to find a way to fire you for sure. Because the last thing they want is for anybody to actually unionize and exercise the rights that they have. So I don't know. You can definitely look around for it, and it's I don't know the particular person that I was referencing. Unfortunately, that was me sort of like speaking a little bit secondhand. But there have been more attempts at unionization in the U.S. In the last year, I think, for Amazon warehouses, and I think you can then find that there have been even more, as a result, reactionary attempts to suppress those unionization efforts, and generally it comes by firing those people or otherwise trying to present them as untrustworthy or something. What do you think of the riots and protests? Yeah, I mean, I am definitely in favor of it. People they have a very good point around the way that the police system in the United States operates on explicitly racist principles. It's not even a question. Like, police agencies go get trained by the DEA, and they train them on how to go into minority neighborhoods, pull people over for, generally speaking, very minor, if any, sort of traffic violation kind of thing, and then use that as a basis or an excuse to try to move into a drug search. And if you harass enough people, some percentage of those people are going to have a little bit of drugs on them. And so then you get a drug arrest, and then your stats go up. Like, this is like in the manual, basically, how to just harass minorities en masse. But the key is they don't do it in every neighborhood. They do it in the poor neighborhoods, and primarily the poor minority neighborhoods, because people don't care. The majority of people in the U.S. will simply not care and not see it when it's happening in those areas and not where they live. And eventually people are going to get fed up with that. And then, it also blends in with the fact that they're like hypercharged on their own feelings of being at war with the population, and the fact that they're trained by like ex-military dudes who aren't even like, there are people in the military who have a conscience and stuff, but there's also some folks who went in the military that definitely don't. And some of those go out and train police officers and how you basically need to be ready to shoot anybody at any time, and that should be your mindset in every situation, is like, be prepared to start firing. And that builds up over time. Then they give them all kinds of guns and vehicles and different, like armor and stuff, and basically they hype themselves up as the most badass military unit. And if you're a military, you need an enemy, and the enemy happens to be all the people that aren't, like extremely obedient, basically, because they won't say that everybody in the country is their enemy, all the non-police officers, but it's anybody who doesn't do everything they say exactly as they say it and exactly when they say it. If you have any hesitation to act with complete obedience, they tend to look at you as a problem. Granted, there is a lot of like leeway there. You can get away with resisting a little bit in terms of just not complying with their demands very quickly. If you are a white person versus a black dude, if you're a white woman versus a black dude, like, you get a little more leeway, but you can only push that so far, and they will absolutely use their deadly force if they feel like they are not being properly respected, let's say. Yeah, and they absolutely use deadly force too much because they aren't, I guess, trained very well in how to not do it, and they also exist in an environment where there's pretty much no consequences. It's very rare that a police killing somebody ends up as a particularly bad result for the police officer. At worst, most of the time, you might have to go work at a different police department because you've technically been fired. So then you go get a job somewhere else with the same guns and stuff, But a lot of times that doesn't even happen. The police decide, no, it's not a problem, or if it really even gets to court, a lot of times the court decides no, or or it's presented in court for a jury in such a way that the jury goes, I guess they were justified. And the laws are also written in such a way that does give them a lot of room for doing such a thing, for killing people and being considered legally justified in doing so. So, the basis for the protest is very, very real, and the fact that there were some riots, I feel like the rioting kind of thing has died down, even though some areas of the media really still like to play it up. Like, it's basically just become protests, and a lot of that comes from just, the situation with the coronavirus. People don't have jobs right now, and they don't have much hope for getting a job anytime soon, or getting money from the government to pay their bills. Like, I don't know, the government is really testing its luck in terms of whether or not you're going to have a huge population of people who are pissed off and have absolutely nothing to lose at this point, because they're failing to do anything properly in regards to the coronavirus. I guess the tactic they're taking right now is just, well, let's reopen everything and we'll act like it's all good, but people aren't idiots. They can see that they have not actually gotten anything under control, so acting like it's all good isn't going to really help. It's going to hurt. And so I don't think the economy is going to suddenly swing back, and everybody's going to get their jobs back again. Jake Tran makes a good video on the whole Amazon wage thing. Do you know which one that is? Working 80 hours a week? That seems like a bad idea, but I guess, you know, to each their own. If he's doing it to himself, it's hard to say, oh, well, that shouldn't happen. At the same time, you know, it's easy for somebody to be their own worst boss. Yeah. No, I'll check it out if you link it. Yeah. So, generally speaking, I'm in favor of the protests and riots. I just think that if they were more organized, they would be more effective. The rioting gets people's attention, and if it were big enough and sustained enough, it could result in a very serious retaliation, which might sort of move things forward in terms of escalation. If there was like the federal government really calling in the troops rather than a little, you know, individual states asking for National Guard, or I guess the states are, the National Guard is per state, so it's just sort of activating their own National Guard. But if they brought in the army or something, that would be a significant escalation. So far, they were able to deal with it just with police forces, basically. And the protests, I'm really glad that they continue, that they haven't just sort of petered out. I think that's primarily because of how many people don't have a job to go to right now, so why not participate? But the way that you could make the people that are capable of doing something about this actually care enough to do something would be through more economic warfare of going on strike, preventing the business of the country from continuing until this gets addressed. But that's really hard to achieve because there's the organization for that just doesn't exist anymore. It might have existed 40 years ago, but it's sort of been strangled over the years by the anti-worker forces in our government and corporate existence. So the test value is going to be this. 2, 3, 4. So what are we going to do? Get rich bribing politicians. Yeah. Yep. The like, I'll check it out. That's, you know, how it works. A lot of other countries, they call it corruption or whatever. But in the United States, that's just how the system works. So we don't even want to call it corruption. We just call it politics. But all, you know, the corporations spend money on political elections, not just, you know, because they just darn believe in gun rights or, you know, abortion rights or whatever. They want to get something out of it, and what they want to get out of it is legal changes that are better for their bottom line, whatever that might happen to be. And So, if you can convince somebody that you were so instrumental in helping them get elected, and you can be that instrumental in their next election, which is always coming up, then you maybe can convince them to vote a certain way on a thing that's coming up. Or maybe you can say, hey, here's some draft legislation for an amendment that we think would be really good for America, by which we mean us. So maybe you should introduce that legislation, because wouldn't you like to be elected again, and wouldn't you want us on your side rather than paying money to your opponent? Yeah, and that's pretty much 80%, 90% of politics at this point. So I don't know. It's about who has power, and the power is not actually vested in the institution exactly. The power is vested in the economic system, and so who has the money is who gets to decide ultimately, regardless of what our democracy says from a legal standpoint. And that's why, in order for you to have a real democratic system, you need a much more even distribution of economic power. Because the one person, one vote doesn't actually mean shit if I have no money and somebody else has $1 billion, because they can just use that $1 billion to impact the behavior of people, even regardless of how the voting works out. Do you want to share what country that is? Because that's also true, right? All of this stuff also happens on the global scale, where, and the United States has been probably the dominant character in this. Oh yeah. So there's a reason. I guess technically it's not a white-run country anymore. I don't know if that's how much of that is a facade or how much of it has really changed since the end of apartheid. But for a long time, it was probably the number one country in Africa, still run by white people up until the early 90s, whenever it they decided, whenever it stopped officially being under the apartheid system. But it's a lot like, you need folks who are on the side of the economic powers on the global stage. And at this point, the biggest economic power on the global stage is the United States. Europe collectively still has a lot of power. So they're a player for sure. And obviously South Africa was more specifically tied to Europe from its historical basis. But if you are an economic power and you want to be running everything in the world, it really helps to have certain countries around the world in various geographic centers where this group is really on your side. So South Africa is probably the one for at least all of sub-Saharan Africa. And I would say Israel is the one for the Middle East. There are homies from the standpoint of the U.S. in an area where you have questionable all the way to completely adversarial relationships. And then in the Far East, Japan is the number one buddy of the U.S. Maybe South Korea following that. South America, I don't know. Maybe it's Brazil. Over time, I think, whatchamacallit, Colombia sort of became more through the whole situation of the drug trade and our involvement in stopping and or controlling it in their country, um, has become more on our side. Costa Rica and Panama and a bunch of other countries. I mean, it's, I don't know. Basically, even when a country is not, you know, our strongest ally or whatever, um, our approach is very much to use our economic might to either get them to do what we want, which is generally like have their country be open to our corporations to use it for, as you say, for abuse, either of resources like natural resources or a population that they can pay very poorly and not care about, you know, human rights abuses or other like things that would be an impediment to very low cost production, um, or supporting them in votes in the UN. There's a lot of like tit for tat kind of like, oh, you know, we'll make sure that you get the aid that we give your country every year if you go ahead and vote our way on this particular issue. Or, you know, we'll make sure that when you go talk to the World Bank for the next round of how much money, like what your loan interest rates are, that goes relatively well because, of course, you could say we're pretty darn close to running the World Bank as well. Like it's all a fucking scam basically that we've set up to make it look like we don't run these countries like they're colonies, but still have almost almost exactly that level of control. Um, yeah, and that's what you get in a lot of these countries. Because you know what is the like. I mean, I think I don't want to reduce it down to a single kind of thing because there's a lot of official Chaffee, thanks for the follow. Um, there's a lot of factors that come into it, but you know, even outside of the economic factors, if you have your intelligence agencies, and specifically the CIA in this case, working to get somebody into power that is most amenable to the U.S.'s interests. So you know maybe some country elects a socialist, and then they're going to work to sort of foment and support any sort of resistance to that leader and try to get them overthrown and replaced with military or some, you know, like Guaido in Venezuela they tried for. I don't know how much the CIA was helping him because that didn't work out very well at all, but they've, you know, that's the kind of thing they've done over and over and over again. Um, the people that they put into power through that mechanism, you know, when they go help in Chile, what was his, or maybe no, maybe it was Argentina. It's, you know, South America is probably the place where it's happened the most, but um, the really sort of brutal right wing guy that came into, I don't remember if it was Chile or Argentina, but um, I'm having a brain fart on that right now. But they're not selecting them based on whether or not those people are going to care about the education or the welfare of the people. In fact, they're probably selecting against that because the interests of our business community in those countries is a like sort of explicitly opposed to the welfare of the people of that country. If the people of that country are more educated and are fighting for their rights and stuff, then it's more expensive to use them as a labor force. It's more expensive to sell things to them. Yeah, I mean, yeah, like, and we also just straight up supported the apartheid regime in their war against Angola. If I'm maybe not I don't know if I'm mischaracterizing that, but like we have supported the what you could charitably call the bad side of most conflicts around the world, because we benefit from when the bad people win, and we just don't care about what happens to the people in those countries, basically. And I say we in the sense of specifically the US government and the capitalists who are sort of directing it, because they're the ones that are benefiting. Me, my friends, and the other people that just work a job here actually don't have any benefit. Like, we get a sort of like very third tier benefit of the fact that we're existing in a artificially enhanced reality. We're sort of like the people living in I don't know if you ever watched like Game of Thrones or whatever, but like in the medieval days, right, they had like the castle and then all the people living outside of the castle farming or whatever. The way I look at it is like the United States is the castle, and even if you're not the king or the royalty, if you're just working in the kitchen in the castle, it's still a way better experience than working out on the fields outside of the castle walls, basically. Meaning red is dead, meaning like communists need to be killed or will be killed or something. Because I mean, that's been a lot of our excuse for supporting the bad guys is, well, they were fighting communism. There's a book that I need to read that I haven't yet, but it's called the Jakarta Method, and it talks about how in Indonesia, and there's a good movie regarding what happened in Indonesia as well, and I don't remember the name of it right now, but back in 1965, they killed roughly 1 million people who were deemed to be communists. Not all of them were particularly involved with the Communist Party or anything. And if you watch the film that came out like 5 years ago or something, where they basically talk to the people that did the killing, because they're relatively still celebrated in the country, you can learn about the details. Like, it wasn't like when the US kills 1 million people, we just do it with bombs, basically. And Vietnam was probably the most horrific manner in which we did it, because we used the like napalm stuff, and so a lot of people burned to death. But in this, they one by one just sort of strangle them or shoot them, and then take them out of the room, bring in somebody else, kill that person with a gun or with a garrote or whatever, strangle them, and then next person. Real, like, insane shit, basically. And yeah, we helped out quite a bit and gave them lists of people to kill. And then this book goes into how that the fact that worked and nobody got in trouble for it in Indonesia because they won, then everywhere around the world, all these sort of right-wing movements that were okay with killing a bunch of other people in their country, decided, hey, look, let's do it that way. Let's just say they're communists, and then the U.S. will give us whatever we want in order to whatever support we want in order to go kill a bunch of the people we don't like in our country and then take power. And it happened repeatedly. And we were more than happy to support them because then even if their enemies weren't really communists, these folks tended to be on our side when they were in power, so it worked out in our favor. So it's like the crucible of communism. I'm not sure which thing you mean by crucible. Is there a crucible of communism as a thing? No, I don't think so. Just the crucible, like it's too generic of a term for me to know what you mean by it. Oh, the book. This book, The Crucible from 2009, about South Korea. I don't think I've heard of this one. Um, hmm. Uh, it might be. Oh no, not that one. Okay. Is it the one about the witch trials? I see. Yeah, I think it probably had a fair bit of relation to the witch trials, kind of like that um, mindset, let's say. And you see that I haven't read the book, so I don't know how much they get into it. I think the book that I was talking about, the Jakarta method, is a little more abstracted because it wants to talk about the whole after that and how the U.S. is involved and all of that. But the movie, which is called like killing the like something killing, um, the act of killing. Okay, yeah. I wanted to say the art of killing, but that would be a terrible name. The act of killing. I thought this was a really. I mean, I don't want to say a really good movie because it's not like, oh, I had a great time watching it. It's actually really, really hard to watch. But the author wrote the play as a metaphor for the Cold War. I see. Okay, yeah. I mean, I think certainly in the United States there was this sort of like anti-communism witch trial fever, um, and you know there's beyond just the play with that as a metaphor. There's probably a lot of like work that could be done or has been done in terms of trying to understand what that underlying psychological basis is for like picking out a person or a character of person as this embodiment of evil and everything that's wrong. And like I watched a YouTube video a week or two ago by Philosophy Tube where he was sort of trying to relate the witch trials and anti-Semitism and how those things have more correspondence than you'd think in terms of like there's such an obsession with I think it was maybe I'm mixing multiple videos together, but it feels like it goes into absurd areas, and it's not like yeah, it's just not about whether or not the accusation or the context or anything is real or has any basis in reality. Uh, it's based around some kind of obsession, basically, and so these people can get really obsessed around um, communists infiltrating everything, and it's easier to look at it and be like, oh, these people are secret communists and stuff, and then it's probably no coincidence how much that like anti-communist stuff in the US is also tied in with anti-Semitism and the presumption that Jewish people were like adherents of communism and tied to it and secretly all communists or something. um it's I don't know, yeah, there's a lot of like hysteria to it, I guess, in the same way that I think the witch trials had that aspect. And also, I guess the video that they he did about the witch trials was really more about how there was a need to undermine the social position of women that they had prior to capitalism, and under a much more regimented economic system that forced workers into this very specific role within society. um, it was the I mean, it wasn't like a conscious decision, but it's just sort of morphed into this like women, their role is to have children so that we have more workers, so that we have people to make us money, working in our factories or whatever, rather than the myriad different sort of roles that they had before, not necessarily on equal footing with men, but definitely as more than just bearers of children. And the fact that witches were part of that, is why they also needed to be excised as a concept, because it wasn't like, at least as what they talk about in that video, wasn't like people thought witches were all evil for all of time before. Um, they were part of the community in the sense of like, this person has, I guess, mystical powers, and you go to them for help in some fashion or another, like, and then it became a like, tied in with religion and all this other stuff, like it became an evil thing, that needed to be destroyed, and also as a became a basis for ensuring that women knew that their place was to not be in any manner disobedient or independent. Because I think a lot of the you can definitely read about the witch trials and where a lot of the accusations and crimes that made somebody be cast as a witch were just like, I don't know, maybe being able to read, or um, doing, being a woman who wasn't living the exact role of just a child bearer and child rearer. Uh, so, but the whole, the sort of hysteria thing and the feeling of like there is some supernatural force at work that is, I don't know, an existential enemy of our society. In the witch trials kind of days, it was the devil that was, infecting these women and controlling them and all their behavior. And then under communism, it's just the idea of communism, or maybe if you're super conspiracy minded, like there's a secret cabal of communists that actually determine and control the behavior of everybody that believes in communist kind of things. Yeah, well, I have trouble imagining it from my life, obviously, but it's really fucked up. Yeah. And, you know, I think the one thing to keep in mind from that is just the whole assumption or whatever that the patriarchal system that tends to exist in all of Western societies these days, and certainly societies that have derived a lot of their culture from Western societies, was not even, you know, a timeless thing or an ancient thing from the societies in Europe and England and all that, let alone obviously other parts of the world. But it, you know, it was a particular thing that really did develop in a particular period of time, and then has continued and grown, and, you know, it's, I guess, you know, the one good thing you can get out of it is just being like aware that if it was a thing that developed and has a real basis within society and economic systems, then it's also a thing that can be removed and changed. And maybe it would require the economic basis and structure of society to change first, or in the same, you know, along with it. But it's not some inherent reality, even though the more conservative folks would be more than happy to have everybody believe that it's actually just pure natural whatever, that women are subjugated and all that. So yeah, if you want to, you know, be kind of depressed, you could watch The Act of Killing, where they interview all these dudes who just did that killing of tens of, I mean, probably on an individual basis, they probably killed hundreds of people, maybe a couple thousand, but, you know, in total, in the realm of 1 million people, because they were, you know, they needed to stop the communists, apparently. And it also goes into the fact that, like, the country still operates on the basis of they are heroes who should be celebrated for ridding the country of the evil communists, basically. Which is interesting because prior to that, they were like, the communists were basically in charge, and that's really why the U.S. was so interested in involved in trying to support these killings, was they wanted to get this country to not be under the control of sort of communist leaning, or an explicitly communist party. So I don't know. It's definitely, it's an interesting book, or an interesting movie, and I would suggest, or at least I'm interested in pairing it with this other book, the Jakarta Method, that then puts it in a broader context of how that went along with these other incidents of mass violence that have been supported by the United States over the years. Okay, I'm going to try to finish this one up, see if I can get something going. So we call this proc. And proc.read until I don't know what does it look like? Just 0 enter. Zero new line, and then proc dot send line. Let's say So we got the seg fault. Seg fault at that address. That doesn't make any sense to me. Let's see if I can. Oh, it's partial rel row, so maybe. Oops. Oh, maybe we can overwrite the GOT with something else. That's another option, I guess. Because maybe the Finney array is not something. What? Oh, I didn't put the. Yeah, so writing there is apparently not allowed. Let's see. So it's at 600 E18. That is a read-only segment. Okay. Then I guess the GOT is in here. That's probably fine. Because, I mean, again, if we can override it with... unless there is some kind of... Yeah, what's the setup function? I don't remember that being called. Maybe I just missed it. But there's no call to system, I think. There's no import for system, right? Nothing like that? Okay. Not that we would be able to use that necessarily. What happens in setup? Then we set up an alarm as well. And oh, it's an entry in the init. Okay, that makes sense. So this doesn't really help us at all. We can find the one gadget and maybe we can write to the GOT. So that's at 600 FF. So the GOT.plt is at 601. What are the entries that are in there? Or no, because we don't. Yeah, I was like, can't we just overwrite the return? But we don't know where the stack is. So how do we? All of this stuff is writable. like the PC. PX, okay. So this is the address that we'll go to for exit, it seems like. Let's look at what that looks like. So, yeah, okay. I don't know why it's called got.plt at this area. But I think we can just override what exit goes to. We do one gadget of maybe do this address, give that a shot. So we want the GOT entry. All right, so let's see. General protection of what? All right, let's. Why is scanf exiting? Because we didn't scan in a full number? Okay, maybe I'm making the number too big in here. Let's do that. Okay, cool. So we do have control over that address now. So let's give this one a shot. No, didn't like it. Okay. Because we don't know where libc is based, so shit, I see. And so we can write one quad word basically. But what do we write? Maybe it's a D word that we write. Do we have to have exit loop back and allow us to write a different location? We have NX, right? So we can't. We don't have anywhere that's writable and executable. And if we don't know where the stack is, well, I think I'm going to leave this one for next time. It didn't come very easily. I'm nowhere near feeling like I need to look at the walkthrough, because I think I can noodle on this a bit and come up with some other possibilities. Now that we definitely have a write that if we replace it with the exit PLT entry, we can definitely get it to jump to wherever we want. I don't know if that is necessarily the approach we need to take, but because I don't know if we can figure out oh, what if, okay, let me try one last thing. So this address is not based anywhere. Then we want to figure out where, no, because that address just goes to the PLT. But maybe, has printf already happened? I don't think it has, unfortunately. Yeah, that only gets called once. I was thinking if we have an entry that has already been called, then we could just replace the lower bytes of that in order to get this value. But I don't think, we have any way to get it to call such a thing. GB isn't called, yeah. I don't know why I'm even bothering to. Oops. Is there an address that would be in memory that will be linked to libc already? I don't think so, that I can think of right now. And this is still under stack pivot, which makes me think I'm probably not even approaching what the real solution here is. So I'm going to leave that for the next stream, which will be on Monday. On Monday, we'll come back and we'll do more binary exploitation practice. Yeah, tomorrow we're going to do try hack me and see if we can hack into some additional rooms. We're still in the penetration, offensive security penetration testing sort of pathway. And yeah, I think we have 1 or 2 more boxes in the whatever section we're in right now. I forget what it's called. And then there's like the mastery section following this. So make some progress on that, hopefully. I haven't done anything to fix my network related issues that were plaguing me last weekend, but maybe I'll get to that before the stream tomorrow. If not, you might just be dealing with that again, and hopefully it won't be so bad. And yeah, we'll keep up with this. Maybe something will occur to me after the stream ends. That happens from time to time. But I mean, there's definitely a kernel of something. It's just a matter of figuring out where to jump to. Or I guess with the exit, we could have it jump back to the beginning of this function, right? And then we could write another set of bytes. I mean, actually, I was thinking that earlier, but the issue is how do we get our stack to those bytes? Which I guess would be the stack pivoting part. Right now, I'm not seeing that. But I'm gonna work on it on Monday instead. All right, thanks everybody for coming and watching the stream. I appreciate it. Thanks Foon for chatting with me about all manner of stuff, really. Apple to mass murder. Maybe not as far as you'd think, but definitely a nice selection of topics. And yeah, I will be back tomorrow. Adios.